Hello students, welcome back to our today's video session class. In the last video class, we have started chapter number 7, Air and Atmosphere. We have already done 2 classes on this chapter. Last class, I have explained you about the composition of air, that is oxygen. We have already discussed up to physical properties of oxygen. Now, today we will start from the chemical properties of oxygen. That first of all, the reaction of oxygen with metals. As you know, metals are slowly or fast reacts with oxygen. So reaction with metals. So when metals reacts plus oxygen, it gives metal oxide, and always remember that metal oxides are always basic in nature. So suppose if I write if you take an example, calcium Ca plus O2, it gives CaO. Okay, now balance it. So metal oxides, when reaction with metal oxygen reacts with oxygen, it gives metal oxides. So similarly, potassium with oxygen, it gives potassium oxide. Magnesium plus oxygen, it gives magnesium oxide, like that. Now reaction with non-metals. Reaction with non-metals. Again, non-metals plus oxygen, what it will give? It will give again non-metallic oxide. Non-metallic oxide you will get. For example, very simple, carbon plus oxygen, it gives carbon dioxide. Very common example. Sulfur plus oxygen, it will give sulfur dioxide. Nitrogen plus oxygen, it will give nitrogen dioxide. Now, rapid oxidation and combustion. What is rapid oxidation and combustion? Combustion is again a chemical process where reactions of metals or some other chemicals with oxygen takes place very fast. So next is the rapid oxidation. Rapid oxidation, or that is called combustion. Rapid oxidation, or it is also called combustion. Combustion means burning also. You can say the burning. Okay. So a type of oxidation in which oxygen reacts very quickly with the substance, that means it is called a oxidation with the release of heat and light energy. So when there is a rapid oxidation, we get some most of the time heat and light energy, and that it also called as rapid oxidation. For example, it takes place in the case of fuels. Any fuels, if you take fuels plus oxygen, what you will get? You will get smoke that contains carbon dioxide. After that, you will get some portion of water vapor, that H2O, in the form of steam, or you can say water vapor, and plus you will get heat plus light also. So this is all about the rapid oxidation and combustion. After that, slow oxidation. Slow oxidation. What is slow oxidation? In this slow oxidation, as the name suggests, the slow oxidation is very slow process, and the energy released here very slowly the respiration and rusting. For example, it is respiration and next is rusting. As you know, both of the things over here, when respiration takes place, oxygen, we need oxygen, and with the release of carbon dioxide. Okay, so oxygen plus glucose, C6H12O6, what you will get? You will get CO2 plus heat energy in the form of ATP. Okay, and rusting, you know this one also, Fe plus O2, it gives Fe2O3.XH2O. So this is the rusting and respiration are the two chemical processes of oxygen properties where slow oxidation takes place. Okay. Have you understood these things? So there are four chemical properties we have seen. First of the reaction of metals with oxygen, reaction with non-metal with oxygen, then so rapid oxidation and the slow oxidation. Rapid oxidation consists of combustion, and slow oxidation example is respiration and rusting, and we have all the examples of all the chemical properties. Okay. Now, next point is in this here, that the use of oxygen. So, use of oxygen, you know already, the oxygen is very useful to all the animal and human beings, because without oxygen we cannot survive. So, oxygen takes place in the process of respiration. Oxygen is itself is not catches fire, but it is a supporter of combustion. If there is no oxygen, there will be no burning also. So these are the two properties, main properties of oxygen, that is respiration process and use for burning processes. Okay, so these are the two main processes. Other than that, it is used in oxyacetylene torch. It is another type of torch, oxyacetylene, or sometimes it is called oxyhydrogen flame also. This flame is used for cutting and welding of metals. Another, it is used in the manufacture of iron and steel. In a blast furnace, oxygen is used to extract iron from its ore. Iron is also used to extract oxygen is also used to extract iron from its ore. So they are the four things that we have seen. First of all, the uses. Number one is the respiration process. It is used in respiration process. It helps in burning. Next is oxyhydrogen flame, that is used for cutting and weldings. And fourth one is extraction of Fe from its ore. So these are the main four uses of oxygen that we have seen. Now next is the renewal of oxygen. How will you renew the oxygen that we are using from the atmosphere or from the nature? It should be renewed again. So here is a renewable source of energy, so its components are also renewable sources. So as in the last portion, we have seen how nitrogen is renewed by the process of nitrification, nitrogen fixation, and then another processes. Similarly, oxygen is also renewed in the nature by the process of photosynthesis and respiration. Since when we are using oxygen in the process of respiration, we release carbon dioxide. This carbon dioxide are taken by the plants for photosynthesis. In return, they give oxygen. So the cycle of oxygen and carbon dioxide give and take is continuing from long time, and it will continue in the future also. So the cycle will continue, and by doing this cycle we can renew oxygen to the atmosphere again. So this is the process of the photosynthesis and respiration. Both these processes are needed to renew oxygen in nature. Okay, so and you know how in the process of photosynthesis plant use carbon dioxide, and in return they give out oxygen. Okay students, so in this video class we will do up to this only, the renewal of oxygen, page number 108. The next video class I will start carbon dioxide. After that, as air quality, and 2 more videos we will need to complete this chapter. Okay, I hope you have understood what I have explained. So for your any kinds of doubt, please ask me in your next doubt clearing class. Thank you, student.